Okay, I hope it's working fine. So everything like in place, and even yeah, I guess it's like all working. If it doesn't work, please tweet at me, right, and let me know. So first of all, thank you everyone for joining. I'm not sure at what part of the world are you, right, and what time is it basically in your time zone. But currently, where I am is basically still pretty warm evening. It's finally becoming a bit of like this warm temperatures that you can actually get outside, like in shorts and t-shirt. So definitely looking forward to see a bit of a change from what we had before. Um, yeah, but basically, what is it about all today, right? For those of you who joining first time, we're gonna be presenting applied machine learning talks, right? And we have quite a bit of like diversity from, like using embeddings for e-commerce, right? And even trying to get like a different modalities, right, of things inside of the model to making the progress in NLP, right? But not in just like any NLP, as there've been like quite a bunch of different changes lately, right, in progress and state of the art and all of the things, right? But actually, for the languages that having low resources, right? And I think it's like really good combination, right? Because on one hand, we have like Facebook AI, right, together with Pratik, right, who's going to be presenting today. And those guys like and girls having like a lot of resources, they having like a lot of data, right? And they having like a lot of compute and money basically, right? And pretty good like researchers and scientists, right? On the other hand, we having this like huge evolving and growing community like in Africa, right? That also having like lots of languages and they're trying to develop like really good machine learning models, right? Work with um, reproducibility, right? They're like trying to work with how to make remove the biases, right? How to build like a good performances. And for me, it's really good combination of the things that currently are happening in the industry, right? We have like big resources, right, and a lot of opportunities, right? But we still have like lots of problems that are very essential for those countries that don't have like enough of I don't know, maybe footprint on the internet, right, or like money behind, right? So it's really good, at least like for me, it's like amazing to hear our speakers today. So for those of you who may be joining like on YouTube, right, because you somehow like found this like link, right, or maybe a tweet or whatever else, we usually use like Meetup, at least like in the starting from 2017 we did, so like last 4 years. So if you would like to hear about like new events that we're going to be organizing, please join us like on Meetup, and you're going to hear what's going to be like cooking there. And we usually try to be like very open-minded, right? That's why we can have like pretty diverse like talks, right, and pretty interesting combinations of technologies, emerging ones and big ones. And yeah, just join us, and you're going to get updates on our next event. We also have a Slack channel. The Slack channel idea is that you can stay in touch not only the day when you have a meetup, right? Because in the past we had like maybe like on a monthly basis, right? Sometimes with a bit more stormy times, right? We might have it like every second month, right? But hopefully the Slack channel is something that you can stay in touch with, like somebody who you were like talking to, right, at the event, right, and maybe keep developing, right? Because only if you keep developing, keep iterating, right, you can actually make the progress, right? Otherwise, it just is exciting spark of imagination that you're hearing something new, right? But if you don't put effort in, right, you don't have any compounding effect of this one. So just like stay in touch with each other. Just like a bit of retrospective how it was, right? This is basically one of our events. I guess like back in 2019, because I mean 2020 didn't really have like any on-site events, and this is like where we originally coming from, right? We're coming from, hey, we are community, right? We would like to have fun, right? We would like to learn something. We would like to share experiences, right? And get better basically at what we're doing. In reality, currently, this is like how my last event looked for me, right? I have my laptop, right? I have my, I don't know, like screen and like other things, right? But it is completely different feeling from the ones that we had here. But in reality, it's still like you, right, who's like on the other side of the screen, hopefully hearing me, right, and my microphone is working. But just like don't try to um, stop developing just because like some craziness happening, right? And I completely understand that like in some countries they're already like more vaccinated, right? And it's becoming like back to old days or normality. Some countries are having like very harder times, right? We definitely keeping our hearts, right, and fingers crossed, right, so that everything gets like stabilized. But hopefully by us also developing and improving, right, improving our knowledge, we can also be the one who might help the next generation of the problems to dissolve, right, and to progress with other technologies, right? So please learn something new, right? Please build communities, right? And it's going to be amazing for technology. It's a bit philosophical, but it's still nice to think that it's not only about tuning a bit of like number of layers, right, and optimizing state of the art, right? It's something that bigger that we can help to improve in this world, right? We also have a GitHub page, right, where I'm trying to push slides. I'm not always like super successful with that because it takes like a while to get the slides, and after I get like interrupted by something else. But I do promise like in the future collect like more of those, right? And maybe the ones from today going to be shared a bit earlier, right? So you can try to start this repository and you're going to get something. I already said about Meetup. Back in the days, we had like sponsors who help us like with pizzas and other things, right? Those days we still, like can have some support basically for streaming that we're using, right? Currently paying out of my pocket, or anything else that we can help our community, right? Maybe we can have some, I don't know, like diversity supports, right? Maybe you can have something else, right? So if you working at the company, right, and the company feeling like supporting machine learning communities and data science communities, just like reach out to me and we can figure out how to use your good desire, right, to actually reach out to the people and maybe get something good out of this one. As I said, it might be a company. Upcoming events, basically, there is nothing set in stone yet, but they have like a few really cool ideas or people that I'm talking to, starting from having conversations of like, outlier detection for 3D printers and using machine learning for that, right, to a bit more bigger scale machine learning and how to preprocess data and other things, right? So stay tuned, right? We're gonna come up with like more updates there, and it's gonna be like super exciting. And as I said, today we have like 2 amazing talks, right? But 3 even more amazing speakers. So we're gonna start first from more, like big company side with Facebook AI. And here I'm super happy to have Pratik with us. And Pratik is a person who has actually worked on this unified computer vision model, right, that using this like multitask learning, right? And multitask learning, especially like lately, I think is becoming just like a new hot trend, right? Because amount of data is huge, right? Like super amazing, right? But labeling that, right, even with contrastive learning, right, it takes quite a bit of effort, right? Let's call it like that. And obviously contrastive learning definitely helps and eases this way, right? That's why we have seen this like a huge development. But I think like multitask learning, especially cooked properly, right, with like multimodal data, right, as we have in the case of Facebook, for instance, right, with images and text and maybe some other modalities that we can, slice it from the videos, right, and get some like audios. I think it's something that definitely would be like a big change, right? And that's why I'm like really super excited to see what Pratik is going to be talking about, like in his talk, right? Because with the amount of data that Facebook has, right, and the amount of like multimodalities that they're having, I think it's like really something that might again have this like ImageNet moment, right? When we started with transfer learning, right, and we got like really good progress like out of pretty simple idea, right? So really looking forward. And the next talk, as I already had mentioned in the beginning, this is like about NLP, right? But not NLP in terms of trillions of parameters that we have seen like lately, but more about how can we make it work, right, for those like thousands of languages, right? Like how can we make it work for those languages that don't have enough of a labeled data set, right? Or even, like not everybody needs to have like labeled data set in NLP, obviously, right? But it still like takes a while, right, to get like really good data set, right? So what is a good advances there, right? What can we learn from African continent, right? And from those amazing speakers who are going to present us from Chris and Bonaventure on the things that they are like presenting there. So I'm really looking forward. And as I said, that's more or less it, right? We are a community event, right? So if you would like to present some of your learnings, right? Or maybe something like as a lightning talk, like nothing really huge, but you did spend some time and now you want to share it with community, just reach out to me. We always looking for, volunteers and sponsors, right? So if you feel that there's anything in this event, right, that might be improved, and there's definitely like a bunch of those things, just like write me, right? And I'm more than happy to enable you, right, to drive this community and change something for better, right? Because at the end of the day, it's a community event that made by community for community, right? And yes, sometimes I'm presenting things here as organizer, right? But it's basically us doing it for us, right? So don't be a stranger, right? Just reach out to me, and we can definitely make it more amazing. With that, as I said, I'm done with my part. I hope that you have heard what I was saying. With that, basically, I will remove my screen, and super exciting to welcome Pratik to the stage. Hey man, how are you doing?
Pretty good. Thank you for the introduction. How are you doing? I'm really excited to be here.
Yeah, it's same here. Same here. I've heard like so many things like that recently happening, like this multimodality from Facebook, right? And also, I think your presentations that your product or whoever was presenting it like to the big audience was also pretty exciting, and there's like many really interesting ideas are there, right? So I'm really looking forward to see what you're going to present. With that, the stage is yours, right? And yeah, I'm looking forward to hear all of this amazing stuff.
Awesome. Thank you so much. I'll just quickly share my screen and get started. Are you able to see my screen?
Yeah, works fine. I can see it.
Okay. Awesome. So, hi guys, I'm Pratik Dubal, and I'm a software engineer at Facebook AI, and I'm excited to present GrokNet on behalf of my team. So, GrokNet is our latest computer vision system for commerce, and this was a collaboration involving many researchers and engineers across multiple orgs at Facebook. So, and this is a completely computer vision trunk that we use. Like, although there are multimodal systems deployed, today I'm only going to be speaking about the computer vision trunk and embeddings that we use for commerce. So, in this talk, I'll give a brief overview and spend most of the time on the architecture, and then cover some experiments which show the gain that we have from GrokNet. So, like, what are the basic steps for product recognition? So the system consists of several basic steps. First, you need to identify where all the objects are with object detection. Then you extract features for every box, which can be categories, attributes, continuous embeddings, hashes, or a combination. And finally, you compare these features against a large-scale index to retrieve and rank the most likely matches. In this example, we are showing only one result, though a real-world system would give a ranked list of guesses. This talk will focus entirely on training a better computer vision trunk to extract features and other aspects from an image. So although we do object detection, product category prediction, we'll essentially be focusing on the embedding aspect of it. And yes. So firstly, like, what are the applications of product recognition? There are way too many. So it can be product tagging, visual search, shop the look, clustering, deduplication, ranking recommendations, and others. So you can think of it like, our aim is to train an embedding model, which would allow us to solve all these different use cases. And the crux of it relies on the embedding. So that's why we're focusing on GrokNet. So this is GrokNet. It is a unified embedding model for product recognition that leverages multitask learning to train a single computer vision trunk, which defeated the accuracy, which defeated the previous state-of-the-art production system that we had at Facebook by more than double for exact product matching. We achieved this by training on 7 data sets across several commerce verticals and used a total of 83 losses, 3 of which were embedding losses and 80 categorical losses. And the trunk that was used to train GrokNet was a ResNext 101 trunk. There's a lot of wonderful related work in production computer vision systems, which extend metric learning using classification style losses, learning from noisy data, and multitask learning. Unfortunately, I do not have time to cover this work, so please feel free to go ahead and read this literature. It's really cool what everyone has been doing in industry and how they have approached the problem of product recognition from different aspects. All right, so for this project, we wanted to ask a key question. Can one model perform all tasks? That is, we wanted a large-scale embedding that can perform exact product recognition, a medium-scale taxonomy that can predict one of 43,000 search queries, and a coarse-grained approximate classification task with about 80 category taxonomies. With GrokNet, we were able to build this, and I'm excited to show you how. So jumping onto the architecture. So we had the GrokNet architecture, and it's a large multitask architecture, and I'll walk through every piece in detail over the next few minutes. The architecture supports 7 datasets, 3 embedding metric losses, and 80 categorical losses. On the left, we have the data loader, which samples a few examples from each dataset and constructs a combined batch. In the middle, we have a deep convolutional neural network with 101 layers. On the top right, we have our predicted embedding, which we use for exact product recognition. And on the bottom right, we have our softmaxes for categories and attribute predictions. Let's dive into the details, starting with the data loader. I will look at how we construct a specific dataset in detail, the home product identity dataset. To train our embedding, we need examples of the same product seen in multiple views. We get annotators to look at images from catalogs that we suspect contain the same product. In this example, the 4th image is rejected since it is too zoomed in to verify if it's the same product. Otherwise, the annotators would draw tight bounding boxes around all matches. While this works very well, the problem is that it's very expensive and difficult to collect, and you may be limited by the original source of data. The images may also be too clean, resulting in a system that doesn't generalize. And as you can see from these examples, these are very good canonical examples. It's not really products out in the wild, and which definitely is not the case when the systems go into production and you're dealing with real world data. So what did we do about this? So we solved this by using another fully automatic technique to generate additional training data with weakly supervised learning. Here's how it works. Let's assume that we already have some product recognition system. You could use any existing computer vision features, even if they aren't trained for product recognition. You run it on a bunch of unlabeled images and then assume that any high scoring matches are all correct. You then feed into this training shown on the right. So essentially, we are doing some sort of we are relying on the features of some other model just to get some weak insight on what are the categories and what kind of data that we can use. Now, when we open the product recognition system box, we can see that the middle 3 steps are exactly the same as I showed in the introduction. You run object detection, you extract features, and then match against a catalog. One key parameter here is that how you threshold good matches from bad ones. Because you do not know the ground truth labels. You're completely relying on a previous production system, which may or may not be trained on product recognition itself. So you really need to be careful about the threshold that you use, because if you choose the right threshold, you may get an incredible gain. However, if your threshold is not properly tuned, you may either leave performance on the table, or you may even add way too much noise into your training data set, which might result in poor performance. And we performed an experiment to understand this, where we varied the matching threshold, and as shown on the horizontal axis, at a threshold of 0 on the left, we have our baseline performance, which is precision at 1 is below 35%. As you increase the threshold, you are essentially allowing more matches and more weak matches to be a part of your data set. And we started seeing significant improvements, up to 27% relative gain in performance. And beyond that point, there are diminishing returns as you add too much noise to the data set. We use this experiment to first identify like what is the optimal threshold which gave us the best trade-off between dataset size and quality. Uh, uh, yeah, before I move on to the next question, like if there are any questions that I can take. Awesome.
No, not really. All good.
Awesome, cool. So moving on to the next section of the data loader. So back to our architecture diagram, we can now look at a second type of data, which we call search query data. So as you can see, like a user can search for a query, they can click on a product, contact the seller may respond, and we can maybe get an image query pair. So we used anonymized search log data from Facebook Marketplace to automatically create a data set of image query pairs. So as I mentioned, like on Marketplace, users can browse and search for products, and then they can buy from sellers by directly messaging them. To collect a data set from these events, we look at specific sequence of actions. A user should search for a query, they should click on a product, then they message a marketplace seller, and the seller responds back. If all these four events happen within a short time, it is highly likely that the user found what they were looking for, and we can assume that the query is relevant to the image. Now, it's important to note that we do not have access to message contents and only know the fact that the users interacted with each other. So although there is an element of multiple modalities involved, like we could look at the text, we do not have access to it. So this is in a way a heuristic to just mine more data. It's like, oh, if you contacted someone and they responded, there is a very good chance that you got what you're looking for. But at the same time, if the seller is really good and they are very good at responding, they might also say like, hey, this is not available. So that might not even be a good match for us. So there is some noise also being added to this. Uh, so this process generated a data set of 56 million images, and where each image had a list of relevant search queries. We can use this data to train one of the heads of our computer vision system. Now, although we are able to generate a lot of high quality data, not all of the labels are correct. So we use some more machine learning to automatically clean the data. Now, going to the data cleaning methods themselves, we use two different methods to reject bad labels. First, we trained a Siamese network model that takes the query and image as input and predicts how relevant the query is to the image. We asked human raters which queries are relevant on a 5-point scale, collecting about 3,500 labels, and plot the average relevance versus the predicted model score. You can see that our models work well since there's a monotonic correlation between predicted and rated relevance. We then thresholded all labels by the predicted score. We then did the same exercise, but using a different model where we trained a separate support vector machine for every single query. So this allowed us to clean our dataset to a good extent. And after cleaning our dataset with both methods together, we showed a relative improvement of over 6% precision at 1 compared to training on the original dataset. This gain is just from removing bad labels. And we evaluated the accuracy on a separate held out dataset of 20,000 human rated labels. So it is very important to note that you can always increase the amount of data that you have by using weak labels. But if you do not account for the noise being added, it's quite likely that you may be leaving some performance on the table. And 6.3% relative is quite significant when it comes to the problem like exact product recognition. We get about 35 or 40% absolute precision at 1. So having a 6.3% relative performance being left on the table is not good. Now, coming back to our architecture diagram, let us now look at the loss functions that we use to train the embedding. So this is essentially the meat of it and what makes GrokNet work so well. Before we do that, let's first consider what properties we want our embedding to have. On the right, you can see an anchor image and a radius around it showing distances that correspond to the same product. We want to learn an embedding space such that a single margin can predict same versus different product, where different products are far away from the anchor point. So in a way, we want to create a sphere of uh, semantic similarity where like the same product is encompassed within that sphere and different products are away from it. To achieve this, we use the arc face loss, which we borrowed from the face recognition literature. It's a part of a family of new classification style losses, including spear face, cos face, arc face, and others, where the basic idea is that every product ID has a class center. The current batch has now every product ID, as you can see over here, a teapot and a table, they will have a class center in the embedding space. And now when you're training this, the current batch will have a series of vectors in the embedding, each called the anchor. And you compare anchors against the class centers. Now, this is very different to previously studied pairwise methods such as Siamese, where you would compare the anchors to each other. Whereas in ArcFace, you compare the anchor to the class centers itself. So in each iteration, you compare every anchor in the batch against every class center from the dataset. Importantly, you don't compare the anchors to each other. So this gives you a fully global optimization compared to pairwise methods. There are some details involved, such as temperature scaling and angular margin penalty, for which we don't have enough time to cover here. And we run this over like 188,000 class centers, and it works really well. However, the great thing about this is that the loss that it converges much more quickly than a triplet or a pairwise loss. However, the big downside is that you have to hold all of the class centers in memory. So you're limited by the number of classes you can learn with. And we were able to scale it to about 188,000 class centers, but it required us to use a large number of GPUs, and uh, it isn't really scalable, which is not the case with other kind of pairwise losses where you just where you just compare the anchors within a batch rather than comparing it to all class centers. So what we did is that we we proposed a new alternative loss function, which we call the pairwise double margin loss. This is a minor extension of prior work on contrastive losses. And you can see from the diagram that the idea is to pull apart negative examples within with a different class and push together positive examples with the same class. We also have margins to reject small and large distances, which tend to be noise. So as you can see in the diagram towards the top, we clip to suppress outliers, and we have a positive loss when you want to pull similar together. So chairs and other instances of chairs should be pulled together, whereas if it's a chair and a table, they should be pushed apart. So the loss is negative. And the advantage of this kind of a double margin loss is that it scales to any number of classes. So if you look at it like we don't keep anything in memory, we only rely on all the batches that we have and all the anchors within a batches. So we aren't really learning spheres that are restricted by size, which was in the case of ArcFace. Whereas over here, we can theoretically have any number of class centers and we can learn all of them. So no constraint on number of classes. However, the issue is that it is less accurate and it is much slower to converge. And this is kind of a trade-off with Siamese and triplet and pairwise methods, is that you need a large number of images for it to converge really well. Yeah. But yeah, that takes a lot of time to train. Talking more about the pairwise loss, so we try to mitigate this issue to some extent by computing on every possible pair across every GPU. So traditionally, when you're computing this pairwise loss and you're using a single GPU, you only do these pairwise computations for every batch on a single GPU. Now, we had the possibility of scaling it to a large number of GPUs and train them over a distributed network. So what we did was we computed this on pairs across every GPU, and we used 96 GPUs for training. So in fact, we got 96 times more pairs of examples than we would have if we trained only within each GPU. And this actually resulted in giving us nearly a 10% relative improvement in accuracy in our held out experiments. So as you can see, like if we have a batch size of G, and we have G examples in a G number of GPUs, we take all of them together, we concatenate the embedding vectors, compute a BG by BG pairwise distance matrix, shard it across different GPUs, and then compute the loss for each one of them. And this really helps because if you do not do that, you're essentially extending the training time, and it can become arbitrarily expensive simply not doing this. So this definitely helps a lot. So we had two good losses, and we were wondering like, okay, we have one arc face loss, which works really well, has been shown to work on a large number of identities in face recognition. But at the same time, we are kind of putting ourselves in a corner by saying like, okay, we are just gonna assume that the number of individual product IDs is never gonna be over 180,000, which in the real world is unideal. So we are like, okay, let's try to come up with a way where we use both these losses. And so what we did was like we used the top 188,000 identities in ArcFace and all identities for the pairwise double margin loss. And with multiple losses, you just add them together with a weighted combination. So as you can see that our embedding was actually trained with both of these losses, where we looked at 188,000 product IDs with ArcFace and about 3 million product IDs with the pairwise double margin loss. And we went ahead and trained the model with this. So coming back to the embedding distances. So now we have a method of separating the same from different products. But what about the rest of this space? We can still organize the larger distances as well by concepts. In our case, we have a rich taxonomy of 43,000 search queries that we can use to organize the remainder of the space. And this is quite important because these concepts are really fine-grained products. They can be a walnut dining chair, and at the same time, you can have maybe a metal dining chair. So these are individual concepts, and there is a very good likelihood that when embedded in the representation space, they might overlap. So we want to get the notion of, okay, let's use the concepts as well to learn a better embedding. And for this, we propose a new loss function, which we call the multi-label arc phase, where the idea is that every concept is a class center, and each product can belong to multiple classes. This is different to ArcFace, where we had a class center for every product ID, whereas now and one anchor image could only be mapped to a single class center. Whereas now we are saying that, okay, a single anchor image can be mapped to all the multiple types of concepts. And so in order to make this work, mathematically, we extended ArcFace to support multiple labels simultaneously. And the basic idea was that each anchor product is pulled towards multiple positive classes, and it is pushed away from all negative classes all at the same time. And we have a lot more details about this, which we have, which is a part of our paper that was presented at KDD. And when we compare this to using just a single concept per photo, we showed a 1.7% relative improvement and overall 11.2% 2% compared to our previous product recognition system when training just on search query labels with softmax in held out experiments. So definitely like just adding the notion of a product being belonging to multiple concepts got around a 2% precision at one gain. So I won't be talking much about the trunk itself because it's a vanilla ResNext 101 trunk, which is 101 layers. So what I'll instead be focusing on is like the pooling that we use. And we use generalized mean pooling. So as a refresher, pooling is the method by which you collapse a feature map at the top of the network down to a single vector so that you can use it as an input to a classifier or an embedding. In our case, the pooling vector is a 2048 dimensional vector. And traditionally, you would just average over all the spatial dimensions. But we show that if you use generalized mean or gem pooling, which has been proposed by many other papers, the power parameter P allows the embedding to concentrate on salient parts of the image for each feature. And just using this gave us a 26% relative accuracy boost in held out experiments. So I highly recommend to try out gem pooling because it works really well. And instead of just relying on performing the mean or the average pooling at every time, you can learn the pooling parameter based on your data set. And maybe there's some hidden gains that you can get. So I highly recommend using gem pooling in your networks. So before we move on to the last part of our architecture, I just want to check if there are any other questions.
No, all good. No questions so far.
Awesome. So yes, so we saw like after gem pooling, our trunk feature was 2048 dimensional, and uh, yes, and we use that to train our embedding. So we actually end up training a 400 dimension embedding, which uses about 1.5 kilobytes to store per vector. Now, this does not work at Facebook scale when you have very large number of photos that you're searching over. There are probably billions of photos that people post, and it isn't efficient when you're spending like 1.5 kilobytes to store each vector. I would also like to note that the other losses that we use are traditional softmax losses, and we use 80 of those based on home attributes, which could be attributes related to furniture, such as walnut or diam, brown or metal, or fashion attributes, which could be something like maybe the type of a dress, or it could be dress shirt, beach wear, or could be like red formal gown. We have all these kind of attributes and categories which we train using traditional softmax losses. So I won't be going into more detail about that. So coming back to the embedding, we are training a 400 dimensional embedding, which takes 1.5 kilobytes to store per vector. Now to minimize this, what we do is we compress it. And we compress this and we literally compress our vectors by a factor of 50 down to just 256 bits using a system called Catalyzer, which is also developed at Facebook AI. And surprisingly, we are able to do this compression without losing any accuracy, which suggests that there may be further gains in the future if we just focus more on this aspect of it. And I won't be going into details about Catalyzer, but the basic idea is that to make the best possible use of the compressed embedding space, you spread out the vectors from each other so that the whole volume of your sphere is used. So in a way, if you think of it, you have a sphere, and there's a possibility that your embeddings are all focused in one side of it or on one face of the sphere. You just spread it out, and Catalyzer essentially does that for you in an optimal fashion. So we use our 400 dimensional embeddings and learn 256-bit hashes, which are spread over the sphere. And At the end, what we do is that we use these 256-bit hashes and compare them using Hamming distances. So yeah, there's some other details that we didn't have time to cover, but that is a worldwide tour of our architecture, what we do, and how we go about it. And as I mentioned, the categories and attributes on the bottom right are standard softmaxes, which are common in the literature. Some are trained with a single label and other with multiple labels. I'll just take a break. Yeah, so I think we can move on to some experiments now. And the first challenging aspect of training such a huge system is that there are way too many combinations. We already have a 101 layer ResNext, which has, let's say, n parameters, and there are m settings that you can configure it in it. And we also have 7 data sets, which gives us way too many things to try. And we wanted to identify like what is the best way to solve this. So in order to resolve this, we started training models with 2 data sets at a time. And we measured how they interact. So we constructed each batch by sampling a certain percentage from each data set. And then between experiments, we varied that percentage. If the percentage is 0 or 100, then we are only training with one data set, although we always tested on both. So you can see that in this case, the optimal solution is to balance fashion and vehicle data sets. So we should set the batch size to be the same. And we did this with combinations of all the 7 data sets and found that this gives a notion of dataset difficulty. Like sometimes you may want to have more examples from a certain dataset simply because it might be harder to do so. And that is what we ended up with. Our batch size distribution was heavily skewed towards search queries because they were the hardest. Because we were making an assumption that, oh, if someone searches for something and they reach out to a seller and the seller responds, then it is a match. So as you can see, it's quite noisy and it is quite hard. And so we ended up giving like 20 examples in our batch where only search queries, 12 were furniture products, 4 were vehicle products, 4 for fashion products, 4 for object categories, 2 for fashion attributes, and 2 for home attributes. So in a way, search queries were the hardest, whereas fashion and home attributes were the easiest. And we then set the batch size for each iteration to be proportional to this measure. And to evaluate a system on a real scenario, we actually went to furniture stores and collected 2,000 photos. And then we then manually associated these photos with those retailer catalogs to create ground truths. You can see that this captures a variety of challenging examples or scenarios, with some products in the foreground and others in the background. And it is what the real scenario is. Like if you think of it from the future perspective, like you go to a store and you're like, I want to know more about this, or maybe I want to have an AR. I have an AR application which would immediately take this product and render it in one of my photos of my apartment. And so it is quite challenging to do so. And so the team actually went to these stores and clicked these photos and matched them to the catalog that we had. So this was for furniture. We also have other test data sets for fashion and vehicles. And we mainly focus on furniture, fashion, and vehicles because those are the top e-commerce categories that we see in the Facebook ecosystem on shops and marketplace. So you perform like offline evaluation. And on these data sets, our new system is more than twice as accurate as a previous system. This is a combination of all of our architecture innovations, data sets, and loss functions, and we are really proud of this win. This is a fair comparison since it's actually the same architecture and number of bits, and both systems were developed at Facebook. A lot of the gain comes from the fact that we are now explicitly optimizing the embedding for exact match, as well as many data sets and losses at once. while the previous system was trained only with large-scale query data with single multi-label loss. So essentially, we ended up with the same architecture. We ended up with the same number of embedding bits. So we did not increase the compute requirement in production. Rather, we identified new learning methods and just squeezed as much performance as we could and got a 2.1x more accurate system. And yes, and both model architectures were the same, and they both use catalyzer, which has a 50x reduction in storage when compared to the floating point embeddings. Now, to actually understand like how much improvement we gained at every data set, we create a chart to give this breakdown. And you can see that across all data sets, furniture, fashion, vehicles, and overall, we improved by a massive margin. And the last data set is for search queries where we tie our old system. And we weren't surprised by this, although we would have liked to improve that as well, but we weren't surprised because the previous system was solely trained on search queries and they were able to get this performance. Whereas we added more data and we did really well on them. Yep. So coming to our production deployments, we deployed our system into production and we covered two use cases here. First, we use our embeddings to predict which images are duplicate or near duplicate from each other. We show a 76% relative gain in precision, measured at 50% recall over the previous system. This is because our embeddings are explicitly trained to have this property. Second, we deployed it in marketplace search. We used GrokNet to automatically augment every product listing behind the scenes with additional metadata. This helps people find and browse products, and which definitely improves the user experience. We measured a 9% relative gain in search relevance quality, meaning the percentage of sessions where so by search relevance quality, I mean the percentage of sessions where all top 10 products are correct. So these are like really good gains, and yep. So that's essentially GrokNet. And to summarize, we presented a new unified architecture, showed how we trained on very large number of data sets and tasks at the same time, and more than doubled the accuracy of our previous production system. Uh, Thank you. I'm really excited to see where we go on from here as a research community, continuing to push the scale and accuracy of these systems. Thank you so much for your time, and thank you for having me. If you want to get in touch with me, feel free to leave me an email or reach out to me on Twitter. Thank you.
Perfect. Thank you for amazing talk. It's so many cool ideas, right? Some of them are like kind of smaller, right? Some of them are bigger.
Yeah.
But it's really great that you pulled them all together, like in like in one work, right? And you got such a great results.
Yeah, like I think in a way we really spent time on understanding where we were losing or what performance we were leaving on the table. And in a way, these are, you think of it like tiny tasks, which we are like, oh, maybe if we do this, we'll get some performance, but we never really do because we are always chasing the big fish. And we said like, okay, let's slow down, focus on them. And we got like 2x the performance.
Yeah, it's crazy. So maybe kind of a bit of like obvious question, and I'm not sure if it's something like under NDA, right? You can just like say that, right? But like, how long was the timeline for such a project, right? Because not only there is like many ideas, right, but there's also like quite a bunch of like compute that attached to that, right? So it's not just easy that like MNI styles that you change something and you see results like in 10 minutes, right? So how was like a timeline, and what do you think like was the biggest time spent basically? Is it like you change something, I mean you and your team basically change something and after you wait like a couple of days, right? Or like what is like your approach basically to validate so many cool ideas? And because I guess those are like working ones, right? But you did test like 10x of like non-working ones, right? So how did you fit like all together?
Yeah, so this is definitely where the Facebook scale helps us. So the timeline for the project is like about like 6 to 9 months, and we also relied heavily on some of the data sets being used by other teams at Facebook. So what we did was like we literally tried to fit their data into our system. So rather than going and annotating all of the data, we tried to reuse as much as possible. And so we spent time on just massaging the data to be used for our purpose. And yeah, the experiments take quite a bit of time with using about 96 GPUs. It takes us about a week to effectively train the model. And sometimes it just takes a lot of babysitting as well to ensure the model is being trained right.
Nice, nice. But I guess like you still have a bit of dynamic approaches of like, as you mentioned, like with sampling, right, with the batch size, right? So you're kind of like trying to validate assumption as early as possible, right? And after like
Yeah,
increasing like amount of data that you're using, right?
correct. Yeah. So for that, like maybe we would be, as I said, like we try to use like dataset pairs, and it's like an evolving heuristic in a way. Like, say we want to identify what's the ideal learning rate. So we would just start with like broad chunks. So maybe 10 minus 4, 10 minus 2.1, and we start training and see maybe in the first 100,000 iterations, like, oh, 10 minus 4 does better. And so we really jump into that, zoom into 10 minus 4 and try to like tweak the learning rate a little bit and try to evolve around that rather than performing a grid search of all possible combinations.
Nice, nice, pretty cool. Another question would be around arc loss, right? And you also mentioned that like pairwise loss was not really working fine, right? Because there's like quite a bunch of it converges like slower. Do you have like any intuition, right? Why focusing like on one product centroid is like so much beneficial, right? And another question would be like slightly in different direction, right? Did you do any explicit like outlier detection? Because I worked a bit like also with e-commerce data, right? And sometimes, I don't know, you're talking about shoes, for instance, right? And you have different, let's say, images of the same shoes, right? And sometimes you have like outlier image of, I don't know, sole, for instance, of the shoe, right? And they all kind of look like very alike, right? And it's a bit of like screwing
Yeah.
up your space, right? Because you cannot really like distance it like too much, right? Because they all alike, right? So did you do any like manual, I don't know, like a simple model basically that would say like, hey, throw away this image because like I don't really care, right? And like what is like a good suggestion for people like working in a similar domain with such a big inventory basically?
Yeah, so I'll answer the second question first. So we definitely face that issue, like because our concepts are quite fine grained at times. So we got shoes which were what we expected, but we also got the soles, uh, and we try to just run heuristics to identify such kind of images or even the classes as a whole, and we grouped all of them together into a garbage class. So
Nice.
in a way, you learn that these are garbage predictions, and you just never like show them. So uh, maybe if souls is a product category which isn't super important for from a product perspective, you just group all of them together into miscellaneous class and learn to predict that miscellaneous class, but never really use it in production.
Yeah, I see. Catch-all kind of situation, right? Nice.
Yeah.
So, like, I also like the part with your catalyzer, right? That is able to, project it like on a sphere, right? And by that, basically condense a bit more like embedding size, right? Um,
Yeah.
did you evaluate like anything else, right? Because on one hand, it feels like if you can, like make it so much smaller, right? Maybe model can be distilled, right? And like a bunch of those like questions in like a Z direction. On the other hand, I do understand that you have like ResNet like 101, right? That is already kind of like helping you out to learn representations like in a valid fashion. You don't want to reinvent like your own ResNet, right? So what was like
Yeah.
alternatives like in comparison to Catalyzer, right? And what did you evaluate around? Or did you already have this one as a working solution and you'd be like, hey, I know that it works, right? I don't want to like spend too much time doing that.
Yeah, we didn't really like experiment a lot with like compression. Like Catalyzer was known to be a good working solution, and we went with it. But the team also has been looking at knowledge distillation, as you mentioned, because we know that the hashes work. Sorry, the 256-bit hashes work. So can we maybe like start with some student-teacher learning to begin with, and then go that route and maybe squeeze some more performance out of it?
Yeah. Or even theoretically, like going in direction of like noisy student, right? When you can get even
Yeah.
more, like stability of the model itself, right? Nice, pretty cool.
Yes.
Yeah, so like maybe like one of the last questions. It sounds like really cool, and there's like many ideas, right? Are there like any plans to push it like also to, I don't know, like PyTorch side of the story, right? Like open source, right, and make the model like into the hub direction, right? Or right now it's more on competitive side, competitive advantage of Facebook, and there's like no plans to making it like available. I mean, maybe it's like more like marketing side of the story, but if you know anything about that.
Yeah, unfortunately, I don't know much about it, like where we are headed with this. But
Okay,
yeah.
totally makes sense. Yeah. So what do you think like is the next steps, right? You already like improve the like state of the art, right? Quite a lot, right? And your numbers, I think it's rarely you can see like in the papers that people improve it by such a huge margin, right? So is it kind of like a
Yeah.
done deal for e-commerce inside of Facebook because you did like such a huge progress, or are you already kind of like collecting the next low-hanging fruits and you be like doubling in performance even more right from there?
Yeah, so we're still looking at it like because this was just a computer vision trunk, and as you like
Hmm.
mentioned right at the start, like there are so many aspects of multiple modalities to look at.
Hmm.
So we want to explore that space more and see, let's see how we can extend our learnings to multiple modalities or different forms of media. Like we should not restrict ourselves to images itself, maybe videos, short form videos, long form videos, and we want to consider that as well because our goal at Facebook is to make every post shoppable. So that is going to take more than images. So we are excited to like explore that territory as well.
Nice, nice. And I guess while we were giving all of those questions, there was like another one from the audience. So the like very last one. Can you talk some of the strategies that you tried that didn't work out? Because like it definitely felt for me that like, hey, there was like a lucky ticket, right? There's like so many really nicely working things. What didn't work out? Like, was
Yeah.
there any like great ones?
Yeah. So let's take like ArcFace for example. Like we wanted to scale it up and see, that maybe ArcFace will work. We don't have to go the pairwise margin route, but it just doesn't scale up. So we wanted to have like 3 million product identities trained with multi-label ArcFace, but that just doesn't work. So that was like one failure, which we realized like, okay, we want to learn a combination of losses rather than just ArcFace, and we went back to our double margin pairwise loss. So that was one big learning is that
Nice.
from the systems perspective, we aren't mature enough to just rely on a single loss. And even for the purpose of embeddings, we still need multiple losses to perform this and gain that performance.
Nice, pretty cool. And I mean, it's not really a question, but more like plug from your side. I did put like your Twitter on the stream itself, like where other people can follow, updates on this one. So and maybe help you with
Oh,
like I don't know, with ideas or like papers or anything else where people should go.
sure. So Twitter is a great place. We also have a Facebook AI blog where from time to time, we publish our papers and try about advancements that we have internally. So that would be another great place to follow.
Nice, perfect. I will try to share the links. Thank you again for this amazing presentation. Definitely like exciting things that I'm like, okay, I should try this one and that one, like a shopping list basically.
Yeah. Yes. Thank you so much. Thank you for having me.
Have a good one. Take care. Have a good
You
rest
too.
of the
Take
day.
care. Bye.
Bye. Cool. Like I don't know how was it for you, but for me it was really like exciting, like set of amazing ideas, right? And those amazing ideas is definitely sometimes like shoving, as Pratik said. It's not only that you can go like for the big fish, right? You can also go for like tiny ones, but you collect like a bunch of them, and suddenly it's like becoming like huge progress, right? So really exciting. And I mean, it's still a bit of the situation where you need to have compute, right, in order to validate such a huge ideas as well. But some of them are like small enough, right, to validate. Cool. I think originally we had like a break, right? Let me maybe just like have like I don't know, like a couple of minutes that you can get your water. And from there, we're gonna start with next one, talking about NLP, right, and lower source languages. So let's get back in 2 minutes. Basically, just get your water right and come back so we don't um, make it too complicated for you from natural point of view. So see you in 2 minutes. Okay, okay. Let's continue with our second one because we're kind of like a bit running behind. Yes, so I'm super happy and excited to actually bring two more people. One of the speakers actually, I think, physically located in Munich right now. So it's basically we almost having it as a actual meetup, right, in offline. But in reality, we're like all remote, right? So I'm really excited to invite Chris and Bonaventure. Let's see if he's alive. Hey, how is it going?
Hello, thank you for having us. Thank you
It's
very
amazing
much.
that you're joining us. Are you in Munich right now, or who of you is actually in Munich?
I am in
Chris.
Munich.
Nice, 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 Chris.
Yeah.
It's pretty cool, right? Because we hosted it like in actual, spaces with beers and pizzas, and now we meeting,
Wow,
like in the screen,
that
right?
is
So
awesome.
yeah, maybe like well, all those things are like done in I don't know a couple of months, hopefully not a couple of years, right? We are back to physical locations and gonna continue with that. How was
That
your
would be
day
great.
going? Is it all good?
Yes, all is going well. All is good. Thank you very much. And Bona, how
Nice.
are you?
Oh, I'm perfect.
How is Bremen?
Bremen is okay. It's a little bit rainy here, but it's fine.
That's cool.
It's gonna get warmer. Anyway, guys, like you have so much great content, and you did like a really great job for putting African continent on NLP map as well. So I'm really looking forward to hear what are those things, right? That not only African communities, but also like some of European countries can also learn, right? Because like a footprint of some of the countries not that big, right? And they still have those big models with trillions of parameters for English only. And I think you can teach us like a good lesson how to do it properly. So the stage is yours. So the audience as well. I'm getting off.
Okay, thank you very much.
Okay. Um. So let me share my screen. 1 second. One second. I'm trying to share the screen.
That's okay. While you're sharing your screen, I could be giving a little bit of intro about us. So my name is Chris Emezue. I am a master student at the Technical University of Munich. I share my time between studies and research in natural language processing. So I work with Siemens. I also am a research intern at Miller, Quebec. Bonaventure is Bonaventure. He's a master student at Jacobs University, also splitting his time between studies and lots of working on NLP, computational biology, yeah, things involving healthcare and NLP. And he's a research intern at Miller. As a matter of fact, he'll be going to Montreal soon for his internship, and we are both working on natural language processing, and we're both passionate about African languages and natural language processing for African languages. This is something we call Africa NLP, and we are doing this with Masakane. Masakane is a community of researchers working on African languages.
Yeah.
Okay. So
So
our
do you see
topic
my
today
screen?
will be on. Sorry, what?
Can you see my screen? Can you see the
Yeah, yeah,
share?
I can.
Okay.
Yeah. We've
Okay.
started.
Let's go.
Our topic today will be an advances in NLP for African languages. Basically, we'll be talking about some of the advances and things that people and we have done, especially for African languages. We are like one in many people in like this Masakane community working day and night and steadily and bringing out things and equipment and technologies to incorporate African languages. So we'll be talking about something called FFR, translate.com, OkwuGbé, and finally we'll be introducing Masakane. Um, our main vision for all this that we're doing is, if you look at the world now, right? Many things are in English. Many things are English centric. That's how we call it, right? Language technologies, Alexa, Google, many things use English, or computers use English. We communicate in English, and that's good. But there are these many other smaller languages that don't get enough recognition. So you have in I think in each country you have those group of languages. In Russia, you have a group of tiny Russian language. In Germany, I noticed like there is a group of, I don't remember the name, but there's a group of very less spoken languages which people are also working on incorporating. So in each country, you have that. Uh, Interestingly enough, in Africa, you almost all the African native languages belong to that. So, for example, Google Translate has over 109 languages, and just 13 of them are African languages, and the rest are like way less. This calls to action, because it's important for language technologies to incorporate as many languages as possible. That's what makes it fair. That's what makes AI fair. And when this is not the case, we need to do something. And it's not the big companies that would do something, or the business minded companies. It's we as native speakers of the language, we as NLP researchers, or we as normal people who have an interest to do something about this language. And so Bonaventure and I are just one of these people who have this interest in doing something for African languages and trying to put African languages on the NLP map. And so that's what led us to FFR Translate. FFR is Fon to French. So Fon is a native language spoken in Benin. If you look at this language map, it's first of all, this language map shows you the diversity of African languages. Like if you look at the map, there's so many colors showing so many groups. And when you even go inside, there's like so many dialects of a language. So in this language map or tree, you have Fon, which is part of the Bay clusters, and Fon is Bonaventure's native language, and Igbo on the right is my native language. And so in FFR Translate, we designed the first Fon to French translation engine. We designed it by, of course, through the machine translation system of gathering data sets, training the model, fine-tuning the model, and making it better. So Bonaventure would take the data set collection and the remaining.
Okay, thank you, Chris, for everything you said. Yeah, so like you mentioned, to start our project, the FFR Fund Functional Machine Translation Project, which is the first of his genre, um, we first of all tried to collect more data because phone is a very endangered. I mean, African languages are endangered, but or low resource, but there is low resource in low resource. So, of course, low resourceness is not just lack of data; is much more bigger. But lack of data, scarcity of data is part of this whole problem. So, first of all, we tried to build a data set. We built two data sets that we call FFR data set 1 and 2. The major sources were primarily GW300, which was made of Jehovah Witnesses, testimonies, and everything translations, and Benin Long, which contained sentences, proverbs, and also some books of the Bible. So initially, we have, like you can see, we have huge number of sentences from both GW and BL, but we noticed that there were some incorrect, incomplete, inexistent translations. And like some sentencing also were mismatching. Like you have a sentence in French, but you don't have its translation in Fon and vice versa. So to overcome that, we now try to bring to put into the whole system what we call human evaluation, which is also actually also I think a big trying a big topic about including human and not just relying on building state of art machines and everything because machines that we build for language technologies have to be efficient and the more we bring in people speaking the language and the more we make sure that technologies are built for those people and for sure also preserving the culture. So after including the natives we now you can see that the quality of the data set dropped drastically, mainly on the Benin language side, almost by quarter, by four, and but it's improved in quality. and that's what the table in front just showed us. So our first model was, I mean, it was first of all a proof of concept to show that the thing is working. So we used the basic standard NLP, neural machine translation architecture, which is basically encoder decoder configuration, and then we add the additive or so-called Badano attention in the middle. I mean, on the decoder side. So like we can see on the table, FFR, I mean, the blue score on FFR1 is way less. The blue and glue being a metric that has been introduced by Google. The scores on FFR1 are way less than the scores on FFR2, and this testifies of the quality. Now, you will see plus DE and minus DE. DE is what we call diacritical encoding. That was also a kind of concept that we put in, and that was also a kind of proof of concept that shows that the diacritics, like the different accents, in our language that controls the tone, that controls the meaning of the sentences, are pretty important. So, for instance, we see it later on in the second part of the talk how like stripping off those diacritics could completely lead to disambiguity even for us people. I mean, yeah. So I've already talked about the evolution of the data set to increase the quality. We are getting more collaboration, we're getting more in touch with native speakers, including myself, and we are now the FFR model that we put online now for like a Google-like translation engine is most likely based on let me say daily data conversation. So we wanted something much more like, let me say, a model. So what we did was creating surveys that we shared on social network, LinkedIn, Facebook, Twitter, and with the people we are working on, the native speaker we are working on, each of us try to use his community, or let me call it his fan base, to get more data. So people were asked basically like what would be the 5 or 10 or maybe 25 sentences that they use more daily. And we gathered, I think, up to 2 or 3 thousand sentences like that. That now, with the French native speakers, I mean, French native speakers, we have now to clean and everything. So, one of so on the modelization part, we are planning to, of course, try the monolingual data concept that had been showed to increase the quality of the translation. Of course, also data augmentation with back translation, and also other architectures like state-of-art NLP architectures, transformers, and also other tokenization methods like the word expression base that we introduced in one of our papers that have been recently presented in EACN that showed great more performance than the word-based tokenization, than the subword unit, and then more also than the phrase-based unit. And on the bigger picture, this is just a, let me call it, first step, because we are now after planning to move between African to Africa, between African languages. And the next stage will be like from Fon to Igbo. Since we are both native speakers of those languages, it might be better to, like, to judge how good the model is doing. Yeah, so as we can see on the right, the left is the website that is publicly accessible to everybody. As we can see on the right, like that's basically simple. The platform is, and we also design a keyboard that is available on the Play Store, and you can put your sentence in French, have the translation in front, and vice versa. So to make it a little bit much more fun, we added a button that we call surprise me. So based on the language selected, it will generate automatically sentences on that language, and then you will have the translation on the other part. So like you can see now, we are having French sentences that have been translated into Fon, and we reverse the process and have Fon that will be translating in French. I will fast forward it and show this form that we made because we are sure that translations cannot, I mean, we are not expecting translation to be perfect. So for that, we implemented this form to allow people actually to um, suggest translations. So they will put the French sentences, they will put the French sentences, and then they will put the score translation, meaning how confident are they that this translation is good. This will help us to gather more data and to improve the quality of the whole pipeline, the whole model. Yeah, so I think Chris, we take on from here for the feedback that we got from the public, scientific public, and everything, community, everybody.
Thank you very much, Bona. So yes, Bona has shown you the website, the FFR Translate. The whole project was a dream we had way back in 2019, if I'm not mistaken, and it's really exciting to see like the dream come to reality now with the FFR Translate website. When we had the dream, we wrote a paper on it, on the idea. It was amazing. We got a lot of feedback from BBC. BBC was the first person to cover, the first organization to cover the work of FFR, and it really helped like bring limelight on the work we're doing. We also have had a feature from the Voice of America and a feature from AI Expo Africa, an international expo on African technologies. Also gave a feature on our project. In Germany too, we had a very interesting, one of many interesting articles written about Fon. Also, Bonaventure's University did a lot of TV coverage on Fon and the work on African languages. In Russia, where we were undergraduate students, we also had some news media writing on the work, and the general thing is like
Sorry.
the general thing is like everyone is fascinated about this idea of finally something, a translation engine or something being done for a language, an African language, a language that you may not find like big tech companies like working on, but finally people are doing something for these languages and for African languages too. I think that was really exciting. It was really inspiring and uplifting to see this many features and accolades and appraisers. Also from Benin, the video that I was just showing was the Benin, the country where Bonner is a native of, where they speak the Fon language. They did, I think, more than one TV shows on it, broadcasting. Back then we didn't have the website out. It was just this idea and the model that we were training, but it received so much support. It was really, really cool. So as Bona mentioned, after the successful release of Fon French and French Fon, naturally we have this vision. The vision started with African to African languages translation, where someone in this language can communicate with someone in another African language seamlessly without using English or French or any of these colonial languages as the center. So we started working on African to African languages with the little manpower that we have, the little resources that we have as students, and we decided to also call for donation and collaboration for the future of the FFR Translate, which involves African to African languages. So we set up a GoFundMe. We talked with organizations, and we're just presenting our work and presenting the GoFundMe. So, and also on the website there's like a donation platform to just donate whatever one can. It could be finance, it could be ideas, it could be anything. So we are open to any form of donation or collaboration to see this vision of a world where all languages are receive the same level of fairness in language technologies. All languages can be used. You can open your Siri and speak in your language. You don't have to always, like, you could know English, but you don't know. You can always also speak your own language. You could translate from one language to another for your language. African languages don't become a thing like, oh wow, they're just there, but they now like gain more presence online on the internet, and you begin to feel them and know what they are and what they look like. So that's the plan and vision of translation for African languages. Just as there is text, there's also speech. And interestingly enough, African languages, and if you look at the African culture, like you see this, that most information, most cultural values are passed down in audio form in most countries of Africa. By the way, Africa is the continent. There are like many countries, over 52 countries there. So, and they have their different ways of life. But in most countries, you see this audio form. So I'm talking about music. I'm talking about telling stories through music, not music like the kind, but I mean through telling stories through the mouth. You know, where your grandfathers tell you stories through the mouth. They pass on values. So it's an interesting form of research that, and it's suffice it to say that the future of language technologies in Africa lies in its speech. If there is something that can be done to extract and use this speech abundance and values in Africa, that in African languages, that would be really helpful. Generally, too, I think the world is also inclining towards speech for things. We're having Alexas and speech technologies where you can easily ask for things and communicate and get stuff done. So the future, speech translation, speech technologies is the future, and that's why we also working on speech for African languages. And that brings us to our next project, which is OkwuGbé. OkwuGbé, which Bona will talk a little bit about, is the project that involves speech for these two African languages. That's my language, which is Igbo, and Bona's language, which is Fon. And before Bona starts, I just want to say it's just the pilot stage. So in the future, just like in FFR, the idea is to work on more African languages. So, Bona, you can take up the talk about OkwuGbé. Thank you very much.
Okay, so like he said, OkwuGbé is a unification of two, let me say, two languages. Oku, like you can see, Oku means speech from case, native language Igbo, and Gbe, which means languages from my native language form. So, like I said, the project's a vision on idea of pilot state to unify languages in Africa and also to empower speech speech translation, speech technologies, right? Like you have on laptops now with Microsoft, you have Cortana. So why not one day say, hey, not anymore Cortana, but hey, OkwuGbé, um, um, name coaching or something like that. Like how was my name uh, uh, or like we say, I mean, use actually speak the language like talk about fun, about Igbo, about any other African languages. So, one of the main motivation or motivational quote that we associate to our vision is the one from Nelson Mandela. Basically, it's like when you talk to someone in a language they understand, then it goes through to the brain, they process it by the brain. But then when you talk to them in the native language, it goes to the heart. And I have such a dictum on my language too, which says that Nue Nuevenimeo Gbemetomenododo, which means like what is dear to your heart, you can only express it best in your native language. So yeah, going ahead, I think we mentioned some problems that we did before. I mean, talking about the speech part, and those problems and challenges are still here. So the main goal is to first of all, the main problem is that things are most likely English centric. Of course, now low resource languages are gaining more and more vision, more and more attention. But African low resource language, I mean, there are still other kind of low resource language like Chinese or from Nepal, whatever, those kind of countries, they are still, or Mandarin or whatever, they are still low resource language. But coming to African, um, they are still not so much, if not known, research about it. I mean, commonly, they are not. We don't know by the at the time that we are doing this recording. We don't know like existing good existing platform that can serve as speech translation systems, for instance, for African languages. And like Chris mentioned before, our languages are most likely tonal. You know, in Africa, where even if when I mean every evening, for instance, we can sit down around a fire, and then the grandparents or the parents, mother or father, will be telling stories, and everybody will be enjoying. And it feels different when the story is told in the native language. It feels different than when it's told in French. Like you can feel it, you can know that you are traveling away, like you are leading the story. So those programs led us to start this project of creating ASR models or systems to ensure that our language are preserved, our culture are preserved, and like Chris also mentioned in the beginning, to make sure that AI technologies and powers and advances models are used for the benefit of all languages existing, notifying again that African languages are more than 20 or 30 or 30, 31st, 31% of the whole worldwide language spoken. So the goal of, I mean, the goal and contribution of OkwuGbé, the paper also that we presented at EACL 2021, uh, the main contribution was the very detailed, comprehensive linguistic analysis that we did for both languages. We created end-to-end speech recognition for Fon and for Igbo. For Fon, there was an existing model, unique existing model, and our model outperformed it. Also, we took part in the sprint of, let me call, Hugging Face, and we had like to run it. It was mainly the efforts of Chris. It was a team effort, but he was mainly the one who did most of the thing, putting the system in place and everything. I was kind of busy with Mila and with exams. So with working, Hugging Face and Wave to Rec, I think we achieved much more better result than what we achieved in this paper. So we are planning to potentially use it and maybe extend the current work, the current paper that we have now. And for Igbo, we have presented a benchmark model. So there've been a lot of hurdles with the data set that we have that led us now to start thinking about a way to collect on our own data, speech data to um, to continue to improve this project. So Chris will take on from now, present the linguistic background of Fon and Igbo and so on. Thank you.
Yeah, thank you very much, Bona. Like Bona mentioned, we did an extensive linguistic analysis of Fon and Igbo languages. The reason being, in order to build a good ASR model, speech recognition model, it's important to understand the language and the language structure and morphology in order to know how to work with it. So the linguistic analysis is on the paper. It's really long, but this table is just like a summary. And at a quick glance, it compares Fon and Igbo, shows you their similarities, like they both have many dialects. Like Fon is 53 and Igbo has 30 dialects. They both have relatively, as you can see, Fon has just 2.2 million speakers. I mean, compared to Igbo, which is like 10 times more. So these are their similarities. We could also see some of the differences, like the spatial alphabet structure. Fon has some alphabets besides the Latin alphabets, whereas Igbo doesn't really have that. Igbo has more of the joining of two alphabets. Another important difference is code switching. That's the last row on the table. Um, Fon doesn't do code switching, but Igbo uses code switching, a lot of code switching. Code switching is where you're speaking in one language and you add a bit of another language, or you're speaking in one language and you change to another language, or you're speaking in one language and you throw in some words from another language. So there has been a lot of, it's a very peculiar, very interesting feature of African languages because of the colonization of some African countries and the merging of the colonial language with the native language. And so you have code switching. But interestingly, it's not all languages that have this code switching. So Igbo has it. The next part.
Lingala also has it.
What?
Lingala also has it.
Yeah, Lingala has it. Yeah. It's interesting that Fon doesn't have it, and it's also interesting, like when you're doing the training a model on it, and like you're having the model output, it's just only in Fon. Whereas in Igbo, you could have something like um, yem this table. So like, give me this table, but you see it's a yem this table. And interestingly, the table is not spelled like Table like English. It's spelled Tebulu. So there's like I think 3 or 4 forms of code switching. It's all in the paper and is explained extensively. So it's to understand that code switching is not like I don't know, like a thing that people do because they are lazy or something like that. It's actually a part of the language. It's not like a linguistic structured language.
Yeah.
So after the linguistic analysis, for the model training and everything, it's important to get data. So we worked on gathering speech data for these languages, and that's another interesting area because when it comes to some African languages, it's very hard to get speech data. The same issue of lack of presence on the internet. The same issue of lack of interest. So many reasons, and it's hard to get data on this language. For Fon, we got this amount of data from a researcher, Dr. Laleye, who had earlier on done some research on Fon. So thanks to his collaboration and help, we're able to get the data from him. These are all the details of the data. For Igbo, it was a bit harder to get the data because, interestingly, as far as we found, that there was literally no speech data that I could find on the internet. It was really sad, and we had to move to license data from the LDC Linguistic Dataset Consortium in Pennsylvania. And their dataset is pretty old, like 2014, 2015, pretty old. It had a lot of problems or things that needed filtering, and it's also not open source, so we cannot share it with the open community, which was one of the goals of this research. So basically, this is the amount of data we're able to get for both Fon and Igbo, and then after that, we went into pre-processing. So pre-processing is what you do to the data set before you feed it to your model. So for the speech pre-processing, it's about sampling it and converting the speech to a spectrogram. For the text pre-processing, because our research, we wanted to explore the effect of using the diacritics on the ASR model. So many of some researchers remove the diacritics completely because it makes the model training a lot easier, as we can see later in the results. But in this research, we purposely wanted to keep the diacritics to see how, if it helps the model and how it affects the model. For Fon, we were able to do some diacritical analysis, which we'll explain later. Unfortunately for Igbo, the dataset already came with the diacritics stripped a priori, so we couldn't do much diacritical analysis with that. Next, Bonaventure will talk about the models and the results.
Yeah, okay. So Chris, you think? Chris, thank you. Chris, you think? So we experienced four different models. I mean, four different model stacks, like you can see on the picture. The main components are residual convolutional networks. That's for our input feature, which were narrowband spectrograms from the speech sample. Now we integrated the bidirectional islands like GRUs and RSTMs. That was mainly for the let me say text processing parts and everything. And we added the additive attention mechanism that has been also a very important element to revolutionizing, improving the quality of machine translation. Of course, now we have self attention and everything. But that was also a very great quick off. I mean, quick, yeah, kickoff. Sorry. So what happened here is we tried separate like RCNNs plus BIGIUs plus BILSTM and plus both of them. Yeah, and then after we added attention mechanism on top. The attention mechanism was added on the decoding part, mainly it wasn't since we used actually the CTC loss. So combining putting the attention mechanism on the CT on the decoder part, I mean that's the on the BIGIU part, somehow forced or forces, that's the main idea, the main theory behind it, the decoder to do some monoanatomic alignment. And this has been proved to improve the translation or the transcription quality or the result from the decoder. And yeah, so here's a picture of the architecture that we just bravely described. So yeah, so we have mainly three blocks, iron, RCNN block, and the BiLSTM and BiGIU blocks and everything. The our feature on the input were normalized before being fed to the CNN layer and the RCNN block and everything. We have then a fully connected or linear dense layer in between before putting away. And the way we put the attention mechanism, somehow we can say we kind of modified it. So all the details of how we did it were have been put on our paper OkwuGbé end speech recognition for Fon and Igbo that I said have been presented at AACM 2021. So you can easily find online, archive or whatever, whenever. Sorry. So as I was saying, and as we can see on this table, um, the best result had been achieved using the attention, I mean, using the whole package, RCNN, BiLSTM, BiGIU, and attention mechanism. The metrics that you can see here, CER stands for character error rate, and WER stands for word error rate. So it's based on the level hash 10, or is also so-called edit distance measure. And there are many components, I think, like substitution, insertion, deletion, and everything. So on both languages, Igbo and Fon, we can see that the attention really brought something and really improved the translation. And like I was saying, the lower the water rate, the better the model. So our model outperformed the baseline of Mr. Laleye or Dr. Laleye to be more precise. And we ran another sprint on with Hugging Face, sorry, using Wave to Vec from Facebook, I think, Facebook AI, and we achieved a word error rate of 14.90 something. So the model is publicly available on the model repository of Hugging Face, and you can play with it. So before handing over and leaving the floor to Chris, here were some predictions and some targets. So we can see that, for instance, the second line where we have "Eo Misa Economy." No, please give me or sell me aqua. I forget what does that mean, but we can see that there has been an insertion of an additional A from the prediction side that was not on the target. The next sentence means is fite agosin like where are you going to? And gosin from the prediction to the target, we can see that there's been also an insertion of a white space. And also from the second character yi, which is, I mean, there's been an insertion of an n from a deletion, sorry, from of an n from the prediction. The next one, the the diacritics has been predicted that's supposedly high should be have been predicted by the model, and on the target it was not. And same thing for the last one. So yeah, we can see basically that those insertion deletion minor character level uh let me say errors could have affected the general whatever rate. Um, but as a native speaker and as many other the native speaker we are working with, this is not so noticeable actually. So when you say, "Hey, Mr. Akpom," like when you talk to someone like that, he won't really notice like you use Akpom, I mean with double A or whatever. The message is has been transmitted, and that's the main thing actually. So it's on the speaking, the writing part that is there is much more open challenge to improve for improvement. So yeah, the both our ISR model are available for the code and everything on the data. And yeah, I think I'm done, and I will let Chris talk about the analysis of the result for Igbo.
Yeah. So yeah, so as Bona mentioned, the results here show that the combination of the addition of the attention mechanism really helps to improve the model. Another analysis we tried to do was the diacritical analysis that I talked about, and basically what you see here is between the character error rate and the word error rate. When you look at Fon and Igbo, in Fon there is a large gap between the character error rate and word error rate, whereas in Igbo it's pretty on the same level, like not much gap. Um, so we tried to look into this, and looking into this gave us performed some ablation studies, and it gave us a insight on the effect of diacritics. So if you remember, the Igbo dataset was already had diacritics stripped off, so it was not the model wasn't learning on the diacritics because there was no diacritics to learn from in the training dataset, whereas in Fon the diacritics were kept. So we observed that because of the diacritics, it's like each almost like each letter of the alphabet. If in Fon, you have the letter plus possible accents of the same
Awesome.
letter, like asontego, asongra, asonsecomflex of the same letter, all in the training set of the model. So this makes the training set for Igbo small and the training set for Fon large. And so, because of the large training set, the model has a lot to learn how to put which diacritic of which letter where and how to put it where. And that's why on a character level, like Bona mentioned in this example, the fourth row, you can see the E in the target and the E in the prediction. The only difference is the accent, right? In the other example he gave with the space and without the space and Gaussian and the space and Gaussian, like the only difference is on the character level. So that's why on the character level you have you can notice the differences. On a word level it looks okay, and of course on a speech level, like Bonnie said, you don't notice the difference. So this gave us some analysis on the effects of diacritics on the model. The diacritics will help the model to know how to pronounce a word when you see it. That's right. It learns how this sound connects with this accent in a word. But for that to happen very well, the model needs to be trained more and needs more fine tuning to make it such that the character error rate and word error rate are on the same level. Whereas when you don't have diacritics, it's a pretty smooth training for your model because it's not really learning any more complex structure besides how the sounds connect with the text. So that's it for OkwuGbé. There were two projects, FFR Translate and OkwuGbé. And now I would like to talk about a bigger umbrella of many more projects working on African languages, and it's called Masakane. So we joined Masakane, I think 2019 or thereabout, and interestingly, we were at this stage of our lives where we're asking, what can we do? We've found our passion for machine learning. We want to do something. And if you look at the world, everyone is doing something on English and their language. Is like in Germany, there's a great research center, LMU, and their task towards low resource translation. And they do a lot of stuff with German languages and with other languages that are not in Germany, right? So what can we do for our language? And around this time, coincidentally, we met Masakane, this wonderful community of work trying to bring African languages to the NLP map. So we worked with them, like we're with them now. We're like avid members of the group helping. It's a made up of experts in linguistics. It's mind you, it's not just African, it's non-Africans too. It's not only
Yeah.
for Africans, it's for anyone. So we have Julia Kurtzer from Germany, Heidelberg University in Google AI, and she's such a wonderful researcher. She developed the Joey NMT, which is what we're using for all machine translations of African languages in Masakane. We have Matthias from Salon University. We have Professor Graham from Carnegie Mellon University, and we have so many collaborators and researchers working and helping in Masakane. We have projects coming to Masakane because I think now the world is trying to include other languages besides English in their tasks. Google is trying to set up with the AI ethics and trying to include languages, Facebook. So Masakane is a place you can come to if you have general interest or something in not only African language, because we have Colin, who is not really an African language speaker, but he's really passionate about doing something for low resource languages, and he's with us. And Colin is just one of many other people. I'm just talking from the top of my head. So it's a community, and the beautiful thing is an online community where everyone is treated the same way. So we came in when we were undergraduate students, and you have professors and really great-minded people, but you're all on the same level. We recently also won the Wikimedia Foundation Research Award of the Year for our collective paper on participatory research for machine translation, which can be found on the internet. We are made up of over 700 plus members, and basically you're free to join Masakane. Like anyone and everyone is welcome to join this effort in any way possible. So there are ways to join. You could start by going to the website, looking at the website, what the whole thing is about. If you're interested in joining the community folder, there's at the end there's a Slack channel. So we use Slack for communications because it's easier to synchronize, and it's better. So you could join the Slack channel and join in, bring in your research idea, and you have many people who are ready to help you and dedicate their time to you, to helping your project. So with that, that comes to the end of our presentation. Thank you for your attention. In Igbo, we say dalo. Dalo is a way of expressing gratitude. And in Fon,
Okay, in Fon we say enochenumi. Same way is a way of expressing gratitude. Yeah. So
okay.
thank you so much for your attention, and we are
Thank you
open
very much.
to your questions.
Dalu, for your amazing talk. It was really great and lots of
That
great
was
wisdom.
good. That was really good.
I will try to pick up more, maybe like next time. Yeah, so first of all, thank you for presenting this amazing work, right? I think on one hand, it does show us you like told us, right? It's not only about making like state of the art, right? But it's actually about helping people to get this knowledge, right? To translate the things. And I think it's something that we as machine learning has been like on a hype for quite a while, sometimes like forgetting, right? So it's not about only about making like a good numbers, right, and good salaries, but also about helping people. So thank you for doing that for your people as well. I got like a couple of questions, so maybe I will just like start with a few of them, and you will stop me like
Yeah.
somewhere. So first question, you started with a dataset collection, right? And I think this is like not really, I don't know, not a new problem, right? Like I've seen such a like a similar work like for Ukrainian language, right? So there's like some other things like for wake up words, right? How do you feel like, let's say, somebody's like trying to collect such a data set for Bavarian language, right? Or Franconian in Germany, right? Just like a dialect, right? Within the Hochdeutsch. Where can they start, right? Do they need to build everything from zero, right? Because like you need to kind of like collect the sentences, right? You need to collect the text, right? You need to do like all this like mapping, right? Or do you have like any recommendations, right? Maybe also for African communities that not covered currently, right? Where they can start with collecting those data sets, right? Or what is a good easy approach and shortcuts so far? Or it's kind of like really complicated?
You want to take that, Bona?
Um, well, I can start and then you complete. Um, so honestly, I cannot find a general answer to the question where can one start, because it
Mhm.
depends on all the languages, on each language. Sorry. Yeah, so for instance, for Fon, we didn't really start from scratch. Like we said, we started with GW300, but then we merged to Benin languages. And after we found out that they were most likely the same kind of content and made of proverbs and everything, but we wanted something that was much more daily contextualized, like, good morning, how are you? What's your day? I love you, and everything.
Mhm.
Then we set, actually, like we said, a Google form, and then we shared. I mean, we are a group of, actually we are four. Chris and I are the ones mainly on the coding and
Mhm.
ML part, and the two other ones are journalists, linguistic students as well. So each of us used his community to now get his users fill that form, and then from that we get much more entries. And yeah, that's basically the the base on which is built our current FFR model, which is available already online. So I would say it depends. It depends, and there will be. I mean, as long as there is the motivation, there will always be kind of a way to find a solution to tackle the problems.
I can add to that because I had a very personal not experience. I was one of the people finding the data, working on getting the data set for fun. Um, and so a practical step-by-step guide. One, there isn't really a shortcut method for it because when it comes to machine learning, there are two most important things: the model and the data. The data is even, I think, more important than the model because the
Mhm.
model is basically learning from the data. So you need to take the strenuous efforts of finding this data set and making it good, like representative of what you want. So if you're starting off with a language, I think what I can advise is start by checking the internet for content on that language. It could be news articles, or it could be a fellow researcher who is doing something on that, maybe on Twitter or something, and you can connect with the person and ask the person questions about maybe questions about the research and then questions about the data. You could find a website that's posting things on your language which you didn't know about before. You could reach them and ask about their data and stuff like that. So I would say start with the internet and find content on your language. Now, there's an interesting probability that you may not find any content on your language, or it may be hard, and that's when you can go to the more physical approach of thinking of maybe researchers or people and trying to reach them directly, personally, and talk with them, or creating your own data set like Bonner did on Facebook and with Google Forms, of calling the community, the language community, to fill out this form and help with whatever you have. So that's my answer.
Nice, pretty good, pretty good. So you mentioned this like a website, and I think it definitely shows or help people to understand like how can I use it, right? Like, is there like any plans or at least like direction to do it like on device translation? So like because it's not everywhere that people have like internet connection to use it, especially for like rural places, right? What is your setup for this one, or do you need volunteers for that?
Yeah, Bonaventure has been very keen on that. His first go-to was an app for it, and
Mhm.
I think we set it on the website because the app would take there were so many resources involved, so we decided on the website first. So definitely we are moving to an app for it. I think the app will come in when we've been able to add more languages and build it around something that people will actually, need and be using, and the app will come in naturally. So it is in our plan, definitely.
Nice. Awesome. Thank you very much. It's really amazing. Like maybe like last question, very generic one. Where people can follow your progress, right? And maybe, like support you somewhere like on the internet, right? You mentioned the community, right? Is it like the default place to go, or is it like anything else that we can forward people to follow your work?
There is they are, let me say instead, our Twitter. Mine is Dossou, and Chris on is Chris Emezue.
Yeah. Okay. Put it
Yeah,
Uh,
on.
it's already
yeah,
showing
it's
there.
already there.
Thank you.
So yeah, basically that's where we share our progresses, and that's basically where
Yeah,
we sometimes discussion and everything. And even Masakane can easily be reached out on Twitter.
yeah.
Also, yeah.
Yeah, I
So
think I think Twitter is the best place. We use Twitter a lot, and we do a lot of Bona does a lot of research stuff at Twitter. That's for sure. The FFR Translate also has like GitHub and other projects, and
yeah,
if you go there, you have like I think it takes you to a GitHub of all the projects we're doing, and that's one place you can like see the projects we're working on at a go and like see new projects that we're working on there.
yeah.
Nice. Awesome. I definitely going to share those links like more and looking forward to see how community can develop and all amazing things that you guys going to build because it's already pretty exciting.
Yeah.
Thank you
Thank you.
so much. Thank you
Thanks.
very, very much for having us today.
Have a great evening. Thank you again. Bye bye.
Okay,
Take care.
bye.
Yeah, I hope all of you got some excitement from this amazing fellows, right? Building it for their local languages and actually helping people to speak, like languages that they were not able to speak, right? Help their communities, right? Or just help e-commerce, right? As Facebook showed in the beginning. With that, I'm really like wishing you a great evening, right? Help those communities maybe with what you can, maybe with dataset, right? Maybe with GoFund that's in the link somewhere, and build something great with your skills and machine learning. Have a great evening. Take care. Till the next time.